Hey everybody, let's give this problem a try. This one looks pretty fun. So there's a block and it's attached to some pulley. All right, so we got two objects. So let's draw the free body diagram for each. Right, here's the block, here's the pulley. Let me draw the pulley a little bit bigger. Here's the pulley. Okay, so there's this tether, right? So for the block, it's attached kind of going this way. For the pulley, see, just take a look at it. It's kind of attached kind of like over here. Okay, and then what else we got going on? For the block, there's the ramp like this, right? So there's normal force, normal to the block. The block has weight. The weight of the block, I'll just write the mass of the block times g is the weight. Okay, what else? Oh, there's friction. Okay, so if the block is sliding down the ramp, friction would be opposing the motion, kinetic friction. And that looks like it. Okay, so we're done with the free body diagram for the block. For the pulley, we have this tension over here. The pulley itself has weight. So the mass of the pulley times g. And then see how it's attached. So by some bearing, right? So there would be a normal force normal to that bearing. And we don't know the direction. Whichever way. Normal force for the pulley. Okay, so now we got both free body diagrams. Let's pick coordinates. So if the block is going down the ramp, how about I'll call that x, and then perpendicular to that, just call that y. For the pulley, I'm going to pick my origin here at the axis of rotation. And I'm going to, how about if I say this is x, this is y, which way is z? So practice your right-hand rule. X is to the right, y is going up, z would be out of the page, which would be this way, right? Counterclockwise. Okay, so then if the block slides down the ramp in the positive x direction, then the pulley would rotate in the positive z direction. Okay, let's see. There's an angle here, which would be right here. And that's it. Okay, so now let's write Newton's laws. So for the block, some forces in the x direction, we got mBg sine theta minus the tension minus the kinetic friction. And I think we got everything equals mass of the block times the x component of its acceleration. Okay, in the y direction, we got normal force minus mBg cosine theta. I think that's it, right? Mass times the y component of acceleration. Now, since the block is only moving this way, there is no y component of the acceleration. So that's 0. That's nice. And then make note that kinetic friction, see this right here, is mu k times the normal force on the block. Maybe let me just write that as a separate line. There you go. It's not as messy. Okay, so we got these, let's call it these 3 equations. Okay, now for the pulley, let's sum the torque about the origin here, and then z direction is counterclockwise. So the torque about this origin from the weight, 0. The torque about the origin from the normal force, 0. The torque about the origin from the tension would be this perpendicular distance, which is the radius. So r times t. That's it. That's the only torque, which is in the positive z direction, equals I alpha. Which I is that? Right here. Let me just write it separately. Okay, this is equation 4. I is 1/2 mr squared. One more thing. The block and the pulley are connected by a tether. Right? So then if you follow, like here's the pulley, if you follow a dot as it travels along this perimeter, right? This dot's moving along the perimeter. The centripetal component of acceleration, you know, it looks kind of like this, right? V squared over r. The tangential component of acceleration would be not 0, right? The tangential component of acceleration would be going kind of along like this, the tangential component of acceleration. But then that's also, there's the tether, which is also accelerating some amount, which is connected to the block, which is accelerating. In our case, that's the x component. So because they're connected by that tether, the x component of the block's acceleration is the same as the tangential component of the pulley's acceleration. And the tangential component of the pulley's acceleration is related to its angular acceleration. How is it related? The tangential component is r alpha. And we just said this is the same as this. So that means the x component of the acceleration for the block is related to the angular acceleration of the pulley, like this. So let me write that as a sixth equation. Ax equals a tangential because of the tether, and a tangential is r alpha. R alpha. There we go. Okay, so math time. All right. Okay, let's see. Hold on. Let me grab this so I know what numbers are what. Okay, so we know the mass of the block. We know the angle. We don't know the tension in the cable. Okay, this is from here, and we know both of those values. We don't know the acceleration. Okay, we don't know that. We don't know the tension. We don't know this. This comes from here. Okay, so take a look at all of this stuff. So already I can solve this for n, plug it in here, take all of this and put it here. So let me do that right now. So let me rewrite equation 1 by combining it with 2 and 3. Okay, so equation 1 is mbg sine theta minus t minus friction, which is mu k times nb from right here. But then from equation 2, right here, nb minus mbg cosine theta equals 0, which means nb is m mass g cosine theta. Right? This is this, and n is this. Okay, keep going, equals max. Okay, and then let me just keep track of my unknowns. Now let me combine these three equations, 4, 5, and 6. Okay, so equation 4, r times t equals I, which is from equation 5, 1/2 mr squared. Oh, m of the pulley. Okay, mass of the pulley. I need to be careful there. Which mass? Okay, and then alpha, right here, is ax over r. Ax over r. All right, And already, like, things cancel. You see this R can go here. And then look, R squared, R squared. Okay, I'm just going to erase stuff. Right, you have it on the recording. There. There, okay. And then now, look, I can take this and just plug it in right there. Okay, so let me just do that right now. MBG sine theta minus T minus mu K MBG cosine theta equals MAX. Okay, and then let me keep track of my unknowns. I only have one. Okay, so I'm just going to take this, move it on this side. Looks like I can factor a few things. MG, and then the leftovers, sine theta here, mu k cosine theta. And then this went on the other side, right? So that's, let's see, MBAX plus 1/2 MPAX. Looks like I can factor AX out of there. There, right? And then I can take this and move it in the denominator. I'm just going to do it. Yeah, right, you have it on video. So if I were writing on paper, then I would write these as separate steps. And there you go. And then you just plug in the numbers in the calculator, something, something, something. Meters per second squared. The acceleration of the block. Done. Okay, hope that was helpful. Keep on studying, and I'll see you in the next video.